Hello and welcome. We are looking at the coordinate plane. Okay, to begin, let's look at coordinate pairs. Here are four examples of coordinate pairs: x1, y1, x2, y1. Notice how they're the same height. They're y1 units up. x2, y2, and x1, y2. So notice, again, these are the same height. They're down low. These x1s are directly above and below each other. These x2s are directly above and below each other. These are in four different quadrants. So the x2 looks like it happens to be a positive number. Same with y1. Meanwhile, x1 looks like it's a negative number, as it's in quadrant 2. y2 also looks to be negative. So just 4 points to look at. In a standard xy coordinate plane, every point can be represented by its displacement from the origin. So this is x2 units away from the origin. If I go horizontally from the y-axis, I go x2 units to the right here, and then I'll go y1 units up, removed from the x-axis, right there to place that point, etc. If I want to find the distance between any of these 2 points, because these are directly north, south, and east and west of each other, like x1, y1 is directly north of x1, y2, I can either count how high up it is if I had increments such as these guys right here. If there was actually a way to count, I could. Or if they were too far away, or if I wanted to try maybe a simpler way, I could use subtraction. Meaning to find the distance between these two, it would be y1 minus y2. Or better yet, the absolute value of them, because distance is always positive. Same with the x's. x2, y1 is this point, is directly east of the point x1, y1. I could also do a subtraction right here of just x2 minus x1, or the absolute values of them. Or I could count them. Once again, if there were increment marks, these could be counted, and that difference would be the same. Okay, let's do 2 examples. What is the distance between the points 5, 2 and 1, 2? Well, if you think about those points right there, if I erase kind of some excess info, the point 5, 2 is right here, and the point 1, 2 is right here. So by the counting principle, I could go 1, 2, 3, 4 units over. So that distance then is 4. Remember, it doesn't change vertically. It only goes 4 units to the right. So you actually can count them. Now, if I wanted to do a subtraction, I would ignore these 2's, or I'd just say 2 minus 2 is 0. And I could just do 5 minus 1, which is 4. If I did 1 minus 5, I get negative 4, but remember, you can take the absolute value of it, and then it is 4 again. What about 6, 7, and 6, negative 4? Same idea. Let's look at where those are. On here, 6, 7, here's 5, 6, 1, 2, 3, 4, 5, 6, 7 up. So here's the point 6, 7, and then the point 6, negative 4 is down here. So I could count just how high up I need to go, because it's directly north and south of each other. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are 11 units away, so that distance there is 11. But if I wanted to do a subtraction with it, I'd make sure that when I do 7 minus negative 4, that I take into account that that's actually addition, which is 7 plus 4. Because remember, 1 is 7 units away from the x-axis up, 1 is 4 units away from the x-axis down. So that total distance is 11. Okay, now what if your distances are not directly above and below? What if they are diagonally displaced from each other, like x1, y1, and x2, y2? Well, for any 2 points, x1, y1, x2, y2, you can't just count this way, like 1, 2, 3, etc. No, because they're not directly north, south, east, and west. Their distances are greater than 1 unit each time as you count down. So there's got to be another way to do it. Well, in this case here, you want to imagine that there's a right triangle being drawn. So remember those other points before, that x1, y1 is directly above x1, y2. Well, draw a height down, and then as x2, y2 is directly east of x1, y2, draw a width across. These are the equivalent of 2 legs of a right triangle, and your distance here happens to be your hypotenuse. So if you look up here at this triangle, which corresponds a little bit to this one. A is being represented as the distance between x1, y2 and x2, y2 in the x direction. And B represents that up and down, that is the distance between x1, y1 and x1, y2 in the vertical direction, in the y direction, up and down. So what you can do is use Pythagorean theorem. Now Pythagorean theorem is a squared plus b squared equals c squared. So I can find D by using that kind of idea. Now what are A and B? Well, A and B represent those legs, and A would be x2 minus x1. What you get to do is do that distance difference, just like we did on the last slide here. Remember, we got to subtract, like 5 minus 1 was 4. That distance is, here's 5, and here's 1. 4 is the distance between them. So and 11 was the distance between 7 and negative 4. Again, it was a subtraction. So I get to do x2 minus x1 to find the value for A. So I can substitute x2 minus x1 for A in the Pythagorean theorem. And B represents y2 minus y1 for the same reason. Now I could do absolute value here. I should, really. But because I'm going to be squaring them, absolute value won't matter. My values will become positive anyway. So if you rearrange the Pythagorean theorem equation, so I put c squared on this side instead. Now you take the square root of both sides. The square root of c squared is c. The square root of a squared plus b squared is literally the square root of a squared plus b squared. I can now substitute some values here. I'm going to substitute x2 minus x1 for A, y2 minus y1 for B, and for the sake of argument, let's say that D is being substituted for C to calculate distance, right? Distance D. So D will substitute for C right there. Inside the square root, you're going to get x2 minus x1 quantity squared, that's for A, plus for B, you'll get y2 minus y1 quantity squared. And that's the distance formula. So it looks kind of complicated. That's why it's really important that you understand where it's coming from, what it means, and everything else, because A is nothing more than the distance between your two x values, x1 and x2. And B is nothing more than the distance between your y values, y1 and y2. So that's super important to recognize, so that way when you utilize this formula, it's not so much a memorization thing, it's more of, I know exactly what I'm doing, just Pythagorean theorem. So let's do some examples. Let's say that here we want to find the distance between the 2 points on the graph. Well, this point here, assuming that these are marked off as 1 each time, this point happens to be 2, 3, and this point happens to be 5, 7, it looks like. Okay. Now, one way you could do this is use the actual distance formula and do the subtractions and such, but I have a very visual idea of what's going on here, and I think it's going to be a little bit easier if I just say all I need to find is the horizontal distance from one point to the next. So it looks like it goes 1, 2, 3 over. Okay. That's the same as 5 minus 2, right? And then it goes up from that right angle 1, 2, 3, 4, which is the same as 7 minus 3. Now I'm trying to find this length right here, which we can call C, because you can think of it as Pythagorean theorem. So if it's Pythagorean theorem, then it's A squared plus B squared equals C squared. That's 3 squared plus 4 squared. Okay. Moving on from there, 3 squared is 9, 4 squared is 16. So C squared is 25. So C is 5. It's not negative 5, as you can take the square root of both sides. You would actually get plus or minus 5, but distance is only positive. So that is 5 right there. I didn't plug things into the distance formula, but I used what the distance formula is, literally. It goes like that. Now what if you didn't have a graph, and what if the numbers were even too big? These ones aren't too big, but what if you didn't want to count and you didn't want to draw it out? Well, you can use the distance formula as well. So let's do that for example number 2. Let's find the distance between the points 6, negative 2 and 3, 7. So I'm going to label this one as my x1, y1, and this one as my x2, y2. Okay, that way I can subtract x2 from x1 and then y2 from y1. So distance formula, once again, is the square root of x2 minus x1 quantity squared, the difference in your x's, then square it, and then the difference in your y's, the distance between them, and then square it. Remember, this is just Pythagorean theorem rewritten in a different way. So this becomes the square root of 3 minus 6 quantity squared plus 7 minus negative 2 quantity squared. So that becomes the square root of negative 3 quantity squared plus 9 quantity squared, which is the square root of 9 plus 81, which is the square root of 90, which comes out to, I think, 3 root 10 if you simplify that one right there. So that's the distance. I don't know what that number is a little bit more than 9, right? It's between 9 and 10. So that's the distance right there. So you can see how this can become a little bit cumbersome. So if you know, or if you're just very good at counting, like I said, these numbers were very close together. The difference between my x's was 3, right? From 3 to 6. The distance between my y's from 7 to negative 2 is 9. And you can use Pythagorean theorem from there. My recommendation is to try and make it look as much as Pythagorean theorem as possible without trying to make it look as much as a big formula to memorize as possible. Okay, now let's take a look at the midpoint formula. Once again, something that we don't want to look to memorize too much. We just want to look to understand. So midpoint, as you know, is a point exactly in between two endpoints where all 3 points are collinear. To calculate any midpoint of any segment, you have to take the average of the 2 endpoints' locations. So in this case, we might have something that is north, south, east, and west of one another, in which case you only need to do one average, just the average of these 2 heights, for instance, and you can find that midpoint, or the average of these 2 widths, and you can find that midpoint. But what if your points are, again, diagonally apart, not directly north, south, east, or west of each other? Then you must take the average of both the x and y coordinates, and then you're going to land at your final coordinate right there. So to take the average of them, like D here, you would have to find the average of your heights. Okay, and to take the average of anything, you must add your values up and then divide by how many values there are. And same with my E point right here, that coordinate location would be taking these averages as well. Add up your x values and then divide by how many there are, which there are 2. So your midpoint location, this M, midpoint location is at the x value, x1 plus x2 over 2, comma, at the y value, y1 plus y2 over 2. So as you can tell, it's once again something that, especially because that distance formula looks kind of, it doesn't look like it, but it uses like the same numbers. There are 2 2's, there's an x2, x1, y2, y1. There's subtraction here. You don't want to confuse yourself. So make sure that you understand what you're doing with it, and then you can apply it in a better fashion. So 2 examples. Let's find the midpoint of segment RS right here. It is important, I suppose, to know what location these are at, but if I want to just look at the graph alone without any sort of formula attached to it, all I need to do is find out how far down do I have to go from R to S. And I know I'm not going right at point S, but I'm going at the height of S. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units down. And then 1, 2, 3, 4, 5, 6, 7 units across. Let's see, 1, 2, 3, 4, 5, 6, 7, 8 units across. So this is 10 and 8. So what I can do with these, this isn't exactly perfect as to what I was talking about with midpoint, but what I want to do is just find half the height of 10, which is 5, and I'll go 5 down. 1, 2, 3, 4, 5. That is my mid value for my y's. And half of 8 is 4. 1, 2, 3, 4. And there's that one right there. So my midpoint would be at that point right there, which is what I was trying to find. So that midpoint right there is at the point 2, 2. Now let's try and exercise that actual midpoint formula this time and see what we can do here on example 4. The midpoint of segment AB is at 2, 1, and one endpoint is at -3, -5. So this one's a little different because this time we have the midpoint, right? So we have to find the coordinates of the other endpoint B. So it looks like for A, we have some x1, y1 value. Okay, B is the x2, y2 value. We don't yet know what it is. So in using that midpoint formula to find the midpoint location, remember it's at the points x1 plus x2 over 2, comma, y1 plus y2 over 2, the averages of your values. Now we know what the midpoint is of AB. It's 2, 1. So if the midpoint is also 2, 1, that means that we know that 2 represents this guy right here, x1 plus x2 over 2. And by the way, we know that x1 here is -3. And then 1 is the same as y1 plus y2 over 2. And y1, by the way, is -5. So what I'm going to do is now create two different equations to now find out what x2 and y2 are. That'll help me find what the endpoint B is. So 2 is equal to -3 plus x2 all over 2. And 1 is equal to -5 plus y2 all over 2. So if you multiply both sides by 2 in both equations, then you will have eliminated your issue with the fraction. Multiply by 2, multiply by 2. So the 2's are gone here and here. Now you have, on the left side for x's, 4 equals -3 plus x2. And you add 3 to both sides, you'll get x2 equals 7. And then over here, you'll get 2 equals -5 plus y2. You add 5 to both sides, you'll get y2 is also equal to 7. So your location of endpoint B is at 7, 7. On a graph, if you want to take a look at that, if you want me to get rid of some of this other stuff right here, I'll keep the RS. A was at -3, -5. The midpoint was at 2, 1, right there. So what we had to do was figure out where B was. So it ended up being at 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 up here. And as you can tell, it does go right through them, which it should. And this is also exactly in between points A and B right there. That is the midpoint. Fiend.